What's going on, everybody? In this video I want to talk about a part of the quadratic formula that we call the discriminant. And the discriminant is the root part, so it's going to be the square root of b squared minus 4ac. So the thing is, sometimes the inside of this root is going to be negative. So b squared minus 4ac is less than 0. And when that happens, then the inside of the root is going to be negatives. It's going to be a negative number. So in some cases, we're going to have complex roots for quadratic equations. So for an example like this, let's say that I have x squared minus 2x plus 10 is equal to 0. So the first thing that you should try to do is to factor it. But if you go to factor this, you're going to come to find that there isn't going to be any factors that is going to get us to this quadratic equation whenever we FOIL it back. So I'm going to utilize the quadratic formula and say that a is equal to 1, b is negative 2, and c is equal to 10. So if I use the quadratic formula, I have x is equal to negative 2 plus or minus the square root of negative 2 squared minus 4, 1 times 10. And this is all over 2 times 1. So if I crunch the numbers here, I have x is equal to 2 plus or minus the square root of 4 minus 40 divided by 2. And so x is equal to 2 plus or minus the square root of negative 36 divided by 2. So if you recall the lesson that we had for complex numbers, we say that if you have a square root of a 36, you can break it up into the square root of negative 1 times 36. And then we know the square root of negative 1 is just I, and then the square root of 36 is just 6. So what we really have is x is equal to 2 plus or minus 6i over 2. And then you can split up the fraction. So you have x is equal to 1 plus or minus 3i. Because we can factor out a 2 in each of these terms. And so when you simplify, you arrive at x is equal to 1 plus or minus 3i. So you can see how we can have complex solutions to quadratic equations. Okay, let's say that I had x squared plus 6x plus 24, plus 34, excuse me, is equal to 0. So again, the first thing that you should do is to try to factor, but there are no factors of 34 such that will add to get 6, so I'm going to use the quadratic formula. So I have x is equal to negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 34 over 2 times 1. And this is going to give me x is equal to negative 6 plus or minus the square root of 36 minus 136 divided by 2. And so simplifying a bit, I have x is equal to negative 6 plus or minus the square root of negative 100 over 2. And then the square root of negative 100 is 10i. So I have x is equal to negative 6 plus or minus 10i over 2. And then finally, I can split up the fraction into the real part here and then the complex part and reduce. So for the real part, I'm going to have a negative 6 over 2, which is just negative 3 plus or minus. And for the complex part, I'm going to have 10i divided by 2, which is just 5i. And these are my roots. So let's do another example of this. Let's say that I had 4x squared plus 4x plus 7 is equal to 0. So normally when you have ugly coefficients like this, like a 4 in front of the x squared term, you'd go and use the quadratic formula first anyway, because at that point it's going to be the most efficient method. So I'm going to say that x is equal to negative 4 plus or minus the square root of 4 squared minus 4 times ac. And a here is 4 and c here is 7. And this is over 2 times 4. So simplifying a bit, I have x is equal to negative 4 plus or minus the square root of 16 minus 112 divided by 8. And then x is equal to negative 4 plus or minus the square root of negative 96 over 8. So negative 96 can be rewritten as negative 16 times 6, and the square root of negative 16 is 4i. So what I can do is I can rewrite this in terms of complex numbers. So I have negative 4 plus or minus 4 times the square root of 6i divided by 8. And so finally, if I split up the fraction and reduce, I have x is equal to negative 4 over 8, which is just negative 1/2, plus or minus the square root, 4 times the square root of 6i over 8, and then 4 over 8 reduces to 1/2, so I have the square root of 6 over 2 times I, and these are the roots. And so last example for today, I have 6x squared plus 3x plus 27 is equal to 0. So notice in this one that I have multiples of 3 for each of my coefficients. So what I can do is factor out a 3, and then I'm going to be left with 2x squared plus x plus 9 is equal to 0, and then the 3 cancels. So I'm left with 2x squared plus x plus 9 is equal to 0, just to have some easier numbers to look at. So this one does not factor, so I'm going to be using quadratic formula. So I have x is equal to negative 1 plus or minus 1 squared minus 4 times 2 times 9 divided by 2 times 2. And then crunch the numbers a little bit, I have negative 1 plus or minus the square root of 1 minus 72 divided by 4. So 1 minus 72 gives me negative 71. Let's erase this little. So I have the square root of negative 71, and negative 71 is a prime number, but I can rewrite this as the square root of 71 times I. So I'm left with x is equal to negative 1 plus or minus the square root of 71 times I divided by 4. And then to split this up into real complex components, I have x is equal to negative 1 over 4 plus or minus the square root of 71 over 4 times I. And these are the roots. So you can see that if the discriminant is negative, then it's going to be very difficult for you to find the correct factors of the original quadratic equation because the factors are complex numbers. It's very hard to see that just through experience. So if you can test the discriminant and see if it's negative inside, then that's your cue to use the quadratic formula to solve the problem, because that's how you're going to be able to find the complex roots easily. So if it doesn't factor and you still have a middle term, you could do completing the square, but it tends to be a little bit more trouble than it's worth, especially if you can just use the quadratic formula and get the same thing. So I hope this video was helpful about how we can use the quadratic formula to find complex roots of quadratic equations. So most of the time in an algebra class, you're not really going to see this, but it does show up, and you have to know how to distinguish a quadratic that's going to have real solutions and one that is not going to have real solutions, because sometimes that will trip you up on an exam or a homework assignment. So need you to know how to do that. So anyway, thank you guys for watching. Stay tuned for the next video. Take care, everybody.